As usual, we're going to draw on what we have and what we're trying to find out. So x is the midpoint of AC. So if I draw a line from A to C, it's going to be halfway through that line. It's going to be there. So I can label that as x. OCD is a straight line, so it must go from point O to point C, and then that line must continue straight in this direction over here. And D must be somewhere over here. We don't have to draw that accurately. And we're given vector xd, which is this line here. We want to find out a ratio between OC and CD. And to do this, we've already given OC. We need to know CD. If we knew, for instance, that CD was 2C, then it's going to be a ratio of 1 to 2. And then we can simplify that down to this ratio here to find out what K is. Now with vectors, they can be added together to give you a resultant vector. C to A is the resultant of C to O, O to A. C to X is half of C to A. So if we work out C to A first, I'm going against C, so that's going to be minus C, and then going with vector A, so it's going to be adding A. And it's going to be half of that because it's the midpoint. Now I picked C to X because to get from C to D, I could go all the way around here if I wanted to, and I would get the same result, but I want to take the shortest path possible, and that's C to X and then X to D. X to D, we're given. So if we add XD on top of this, that's going to be adding 3C minus half A. I'll probably put that in brackets to begin with just to make sure you are doing that correctly. Say for instance you were subtracting that, then that's not going to become negative. That's going to become a positive because you're going to have a double negative there. Half of minus C, that's minus 1 over 2C, plus half an A, but we've also got minus half an A, so that's going to cancel out. And then we're adding 3C to that. Minus half a C plus 3C is the same as 3C minus half a C. So we're going to get 2.5C here, or 2.5C if you want to put it as a decimal. There's actually a slightly quicker route we could take here to get that without actually doing much algebra at all. And that's if we consider that X is the midpoint of A to C, then this line here, that's going to be parallel to A, and it's half of the distance of A, because it's half of minus C plus A. If I'm going from C to A, half of that distance we've seen. We're going plus A minus C. We're going to see this visually. It's going against this vector A, and it's going half of that in the opposite direction. That must be minus half A. So if we consider that we've already done that minus half A, then this vector from here to here, if I call that point Y for now, Y to D, that's going to be 3C. Because from X to D, I could do X to Y, and then Y to D. Now I've explained that in quite a long-winded fashion. You could just understand it in your head just by simply thinking, okay, that must be 3C in that direction. And then this distance from Y to C is half C. So this distance must be 2.5C. So OC, that's equal to C. CD, that was equal to 2.5C. Now to simplify this ratio down so that the value for CD is 1 part within that ratio, we need to divide this by 2.5C. So we also need to divide the other side by 2.5C. C over 2.5C, the C's cancel out. So C divided by C, that's going to give you 1. We have 1 divided by 2.5, which you could do long division if you wanted to. We could do 2.5s into 1. That doesn't go. And then it goes 4 times, so we get 0.4. Alternatively, we can just put this as a fraction and make this so that they're both integers. So 2.5 if I times that by 2, I'm going to get 5. And this 1, if I times that by 2, I get 2. It's possibly slightly easier. I get 2/5 as the value of K.